For this video, I am operating under the assumption that you are familiar with the parent functions of both the sine function and the cosine function. So kind of how they're made up. These are the parent functions right here. We've got sine is this top graph and cosine is this bottom one. A couple of things to note from just the differences between them. The sine graph typically goes through 0, 0 because sine has an x-intercept at 0, since on the unit circle, at 0, the y value is 0. But on the unit circle, at 0, the x value, which is our cosine values, is 1. So at 0, cosine of 0 is 1 because that's the x value at 0. And sine of 0 is 0 because that's the y value at 0. So you can see that difference between these two functions. Sine has a point at 0, 0, and cosine has a point at 0, 1. So sine kind of goes to the origin, cosine starts at the top of the graph. That's the main difference between the two graphs. And you could get other points on these parent function graphs by finding more points on the unit circle. But I'm not going to get into that part today. What we're going to practice is how to graph when we change either the amplitude or the period or both for sine and cosine functions. So remember, a period is kind of where the graph starts over because sine and cosine graphs are both periodic functions, which means they repeat themselves. So this would be an example of a period because right here, the graph would start over and do the same loop again. But really your period could start anywhere. I could have said that from this point to this point was my period. Just wherever that graph starts over again, that counts as a period. So for the parent function, the period is 2 pi. And for a parent function, the amplitude is 1. That's true for both the sine graph and the cosine graph. Amplitude being how far away is the maximum from the middle of the graph, or how far away is the minimum from the center of the graph. So let's look at what that looks like if we change things up a bit. We're going to start by doing some sine functions first. So for this first sine function, there are two things that are going to be different about it from the parent function. First, we have this 2 out in front, which changes the amplitude. So for this graph, our amplitude is going to be 2 instead of 1, which means instead of the graph only going up to 1 and down to -1, it's going to go up to 2 and down to -2. Also, this negative, just like any function, is a reflection over the x-axis, which for a sine graph basically means that sine graphs start at the origin. Instead of going up first, we're going to be going down first. Period is found by taking 2 pi divided by b. B is represented by the number in front of our variable. In this case, I'm using theta as a variable instead of x, but they operate the same way. Because this function just has a 1 for b, there's no number in front of the variable, then that means our period is just 2 pi divided by 1, or 2 pi. So that part is going to be similar to the parent function. So when I'm doing a graph, how I like to get started, especially if I have a blank canvas, a completely blank graph to start with, is whatever my period is, I put that 4 tick marks over. So I'm going to call this 2 pi, and then I'm going to go 4 tick marks in the other way and call it -2 pi. And then I label the other tick marks accordingly. So like this would be pi, this would be -pi, which means this is half pi, or pi over 2, and this is 1.5 pi, or 3 pi over 2. And then same thing over on the other side, but negative. Sine functions start at 0, 0, unless there's a phase shift, but we're not doing any phase shifts today. So it starts at 0, 0. And like I said before, typically sine graphs go up first. So typically we'd be going up to 2, but because there was a reflection, that means we're going to go down to -2 instead. So everywhere where I have a tick mark labeled, because I did it based off of the period, we're going to change direction, and it's always the same kind of pattern. So in this case, we went down first, then we need to go back to middle, then we're going to go up to 2, and then back to middle. And then it would keep going. So then it would go back down and so on and so forth. So filling in the negative side, I need to go up to continue my pattern. Back to middle, down, back to middle, up. And so I have just short of 3 periods. Well, really 2 periods plus a little bit here. And it would just keep going with that same pattern. Okay, so that's the basics of how I do it. If I had a graph that did not look like how I wanted to set it up, then I would adjust it later, but we'll get to one like that here in a couple examples. So let's try another one. This time I'm changing things a little bit. The 3 is going to change the amplitude. So that means we're going up to 3 and down to -3. That means our range is changing from -3 to 3. And we have theta over 2, which means I could rewrite that as 1/2 theta. So in this case, our b is 1/2. B is the number in front of the variable. And so to find the period, remember our formula for finding the period is 2 pi over b. So if b is 1/2, we're going to take 2 pi divided by 1/2, which is 4 pi. So because my period is 4 pi, I'm going to label the 4th tick as 4 pi. And then I'm going to divide it into 4. So this would be 2 pi, which means this is pi, and this is 3 pi. And I'm going to label the other side the same way. Don't know why I skipped -2 pi. Okay. So sine functions, as long as there's no phase shifts, start at the origin. So I'm going to do that, 0, 0. And then it's positive, which means we're going to go up just like the parent function goes up first. And we're going up to 3. So everywhere I labeled one of my little tick marks is a change. So up to 3, back to middle. Down to -3, back to middle. Up to 3. Then I'm going to fill in the other side also using that same pattern. And then I'm going to connect it to create my sine curve. Let's do one more. This is example 10 off of your notes, if you want to put in another example there. So 2 things are changing. We have an amplitude of 4, which means we're going to go up to 4 and down to -4. And our b is 2, which means our period is 2 pi over 2. Ooh, whoops, don't know what I did there. Or pi. So our period is pi. That means I want my 4th tick mark to be pi. And if a graph is given to you and it's already labeled, what I do is just out to the side, I draw my own. So I want my 4th one to be pi, which it actually is in the graph that's given, but that's okay. So I draw what I want out to the side. So let's see, half of pi is pi over 2, which means each tick mark in my example is pi over 4. That means we're going to be moving every pi over 4. Sine starts in the middle. We're going to be going up to 4 and down to -4. Start in the middle. It's positive, so we're going to go up first. So up to 4 at pi over 4, back down to the middle at pi over 2, down to -4 at 3 pi over 4, then back to middle. And then I'll fill in the other side as well. And then with this, I can transfer what I know over here. So I've got x-intercepts at pi and pi over 2 and 0 and negative pi over 2. This is a pretty easy transfer, but it's not always so easy. And so you can kind of continue that pattern. You can see that the x-intercepts are happening every pi over 2. So you can continue that. And then it looks like our maximum values, or our relative maximums, are happening at pi over 4. And then we've got another one over here at negative 3 pi over 4. And minimums we can put in and then we can connect all of our curves. So before we do some, oh, nope, just kidding. One more sine graph. So last sine graph. This time our, we've got a negative. This is number 8 on your notes. Negative is a reflection. So it's going to be upside down from normal, which means we're going to go down first instead of up first. 8/3 is our b. That's going to change our period. So period is 2 pi over b. Or in this case, what is that? 3 pi over 4? 6 pi over 8, which reduces to 3 pi over 4. So our period is 3 pi over 4. Okay, so this is a tricky one. This is a good one to kind of do where we kind of sketch our own graph out to the side first. Our amplitude, which I also should have said, is just 1 because there's no number in front. So we're going to be going up to 1 and down to negative 1. We're just going to be going down first because it's a reflection over the x-axis. And because our period is 3 pi over 4, I'm going to make the fourth tick mark 3 pi over 4 in both directions. And why I go in both directions is because typically when we graph these trig functions, we want to graph at least 2 periods. So I do 1 period to the right and 1 period to the left. And once I have my 4, so these would be going up. If I take 3 pi over 4 and divide that by 4, I'm getting 3 pi over 16. That means each one of these tick marks is going to be 3 pi over 16. So this one is 3 pi over 8. Yeah, and so forth. I am going to just label negative 3 pi over 8. Okay, so sine means we start in the middle. We're going down first this time. So we're going down to negative 1 at 3 pi over 16. Back up to middle at 3 pi over 8. Up to 1 at, oh, what is that? I don't know. And then back down to middle. It's too late for me. Okay. And so let's graph that on our graph. And it's not going to come out super pretty. We're just going to do the best that we can. So we know we've got an x-intercept at 0, 0. We've got an x-intercept at 3 pi over 8. So if this is pi, then 1/2 pi I can figure out, and 3 pi over 8 is going to be before 1/2 pi. And then I've got another one at 3 pi over 4. Oh, that one's going to come out real nicely. And then in the other direction, obviously the same. And then we're going down first. So just between those 2 points, 0, 0 and 3 pi over 8, we're going to go down to, oh, just 1. And then we're going to go up to 1 between the 2 points. And then we're going to keep following that pattern. As long as you have 2 periods, that's good. We're going to do some cosine graphs too. We'll go a little bit more quickly through the cosine graphs because they work really similarly to sine graphs. The main difference, again, is that cosine graphs do not go through the origin. They start up at 1. And again, that's because cosine of 0 is 1. Or in other words, when we have 0 degrees or 0 radians, our cosine value is 1. So it typically starts up, but the difference, as we'll see here in a couple examples, is when we have a reflection, it's going to start down at -1 instead. Everything else works really similarly to the sine function. So this first one, the only thing that we're changing is the amplitude. The amplitude is 4. There's no b, which means our period is just 2 pi. 2 pi over 1 is just 2 pi. So that means I'm going to label my 4th tick as 2 pi and -2 pi. Cosine graphs start up at 1. This one is positive, so it's going to start up at 1. And then we're going to follow the same pattern. So, hold on. My amplitude is 4 though, so let me draw in a 4th and a -4. So I'm not starting up at 1, I'm starting up at 4. So then down to middle, down to -4, back up to middle, all the way up to 4, and back down to middle. Then we're just following that pattern. Okay, we're changing a bunch of things on this example. This example is it number 7? Yeah, number 7 on your notes. So on this one, we have a reflection, which means we're going to be starting down instead of starting up. Our amplitude is 3/2. So when I say we're starting down, I mean we're going to start down at -3/2, which is -1.5. And our b is 4, which means our period is 2 pi over 4 or pi over 2. So this one is going to change really frequently. I'm going to sketch, like I did previously, a little graph out to the side before I put it on the graph that's given. Again, I like to do this because I like to do a quick graph where I know the 4th mark is what my period is. So I can figure out exactly every time I'm shifting from up to middle to down to middle to up to middle. You get it. So if each one is pi over 2, that means halfway is pi over 4, which means each tick mark is pi over 8. Our amplitude is 3/2 or 1.5. Cosines typically start up, but because this one's negative, we're starting down at -1.5. And we're going to go up to middle, all the way up. Oh, not that far though. 3/2 is 1.5. And that looks like it's not over pi over 4. There we go. Back to middle, down to -3/2. Then I'm going to fill out the other side as well. Okay, and so when I go to transfer that on the graph that was given, I can see my x-intercepts are at pi over 8, which isn't on this graph. This graph is going up by pi over 4. So pi over 8 would be right here. And my second one is between pi over 4 and pi over 2. So let's see, we've got pi over 2 here. So there's our x-intercepts. Our x-intercepts are happening every pi over 2. And by every pi over 2, I mean every pi over 4. which, I mean, I guess technically they are going up every pi over 2. Okay, and then we're going down first, down to -1.5. So that's at 0. We're at -1.5. And then here we're going to be at 1.5. -1.5, +1.5. -1.5. And this is a lot more than 2 periods. You wouldn't. 2 periods is what I want. This is a lot of periods. Oops, I forgot to put a point up there. Okay, one more example. This is number 9 from your notes. This one's pretty similar to the last one, but a little bit trickier. We have a reflection again, which means we're going to be starting down instead of starting up. Our amplitude is 5 over 2, or 2.5. And because we're starting down, that means we're going to be starting down at -2.5. And our B is 2/3, which means our period is 2 pi divided by 2/3, or 6 pi over 2, which is 3 pi. So our period is 3 pi. We haven't had that one yet. So whenever it's a little bit funky, I just draw it out to the side. This is 3 pi. Right, if we cut 3 pi into fourths, that would be 3 pi over 4. So these are going up by 3 pi over 4. Or half of 3 pi is 1.5 pi, or 3 pi over 2. Our amplitude is 5 over 2. I'm just literally labeling it 5 over 2 and -5 over 2. And we're starting down. So I'm starting down. I have an x-intercept at 3 pi over 4. I go up. I have another x-intercept here. I should probably figure out what that is. And then I go down. And then we continue that pattern. That's just a little bit over 2 pi. Okay, so let's graph all of our x-intercepts. So we've got an x-intercept at 3 pi over 4, which this graph is going up by pi over 4. So 3 pi over 4 would be right here. And we've got another x-intercept at 9 pi over 4, which is a little bit after 2 pi. These are going up by pi over 4. So that'd be here. And then in the other direction, we've got one at -3 pi over 4. And negative. Okay, and then our maximum is about 3 pi, or is at 3 pi over 2, or 1.5. And our maximum is 5 over 2, which is 2.5. And then following the pattern, that means we have another one right over here. All right, let's connect them. That's it.